As I mentioned earlier, armatures have a few more spaces than other objects in Blender, but all of these spaces are just coordinate systems that have different reference points. Now I'll do my best to explain them all here, but the two main ones that you need to know are just world space and local space. If you don't quite follow along with everything else I explain, don't stress too much. It will most likely make sense to you later down the track. I found it really confusing when I was learning this, but then one day, all of a sudden, it just clicked. They're all just coordinate systems with different reference points. I've said that twice now for a reason. That's the thing that I want to sink in. They are just coordinate systems with different reference points. I wish someone had said that to me 3 times when I was learning. It would have helped. Okay, let's get started. Now for simplicity, in these examples, I'm only going to be talking about the location because I think it's easy to understand, but it is applicable to rotations as well. Let's do this. World space, which is also called global space, is a coordinate system relative to the origin of the scene. Now the origin of the scene is down here where these axes meet. So our monkey head here is 3 spaces to the right on the x-axis, so it is the positive x, and 3 spaces up on the z-axis, which is positive z. We have a world space of 3, 0, 3. Now world space includes everything that puts it in this location. That is parenting, constraints, drivers, whatever puts it in that position gets included in world space. So just to reiterate this, over here I have this silly little armature object which is parented to this monkey head. It thinks it's at local space 3, 0, 0, but in world space it is 1, 2, 3, 4, 5. It is 6 spaces to the right and then 1, 2, 3 spaces up. So it has a world space of 6, 0, 3. I like to think about world space is where you see it in the world is what you get, or whizzy wiggy gig. Pretty sure I said that correctly. Local with parent. Now this space type is only available for bones or armatures. This is where the bone properties are actually evaluated relative to its rest position. That is where the bone started in edit mode. So here is my child. If I jump into edit mode, you can see it's in the same spot. Its local space is 0, 0, 0. If I move this 1 space to the right, which is positive x, we've got a local space of 1, 0, 0. Now I just have a marker bone here. This is just for visualization purposes. This is where it was in its rest position. So local with parent actually includes the changes made to a parent. So if I move our parent up, it's actually the changes here. So we've got 1 in the x, 1 in the local y. And that also includes any changes to any of the parenting along the chain. So if we move the grandparent along, it's the changes from here to here. And bear in mind, this local with parent also includes any transformations that may occur from constraints or drivers. So local with parent includes its own transformations, it includes the parent transformation, and it includes the transformations by constraints and drivers. It's basically the changes from its rest position to its current position. When dealing with objects, local space is always relative to the parent. And if the object doesn't happen to have a parent, you can think about it as being parented to the world. This monkey head doesn't have a parent, so its local space is relative to the world. It is 3 to the right and then 3 up. On the z-axis, this is its local space. Now because it doesn't have a parent, it is the same as world space. But however, our armature object over here is parented to this monkey head. So its local reference space is the monkey. So that is why it's 1, 2, 3 spaces in the positive x. Now if we rotate this and we select, it still thinks it's 3 spaces to the left because it's relative to the orientation and the position of our monkey head here. Now when you're dealing with bones, local space is relative to the parent. So here I have our child and here is the parent, but there's one key difference with bones, and that is the starting position is always offset to its own local edit mode. You can see it's in the same position in edit mode and pose mode. So that means rather than it being 1 in the positive x and then 1 in the positive y as a starting position, it's going to be offset and the starting position will be here. So this is 0, 0, 0. Now local space includes any transformations on the bone. So say if I move this to the right 1 space, that will affect its local space, that is a change, as well as any constraints or drivers that move the position or scale of our child bone here. But if we move the parent, let's say we move it up 1 space, that does not affect the local space of our child. So just in summary, local space includes its own transformations. It also includes any transformations from constraints and drivers, but it does not include any parent transformations. Pose space is another space that's only applicable to armatures, and that is where the bone properties are evaluated to the armature's object level. And that means the origin point of our armature here. Now, there's one thing to note before I go any further. If the armature happens to be at world space 0, 0, 0, then world space and pose space is going to be exactly the same. So that means our child bone here is at pose space 1 in the positive X and then 1 in the positive Z, because that is the orientation of our object level. And it's also the same in world space. However, if we move the object container, let's just move it one space to the right, pose space for our child here is still 1 in the positive X and then 1 in the positive Z, although world space is now 2 in the positive X and then 1 in the positive Z. So it might be helpful to think about pose space as being object space, that is relative to the object container. And our final space is transform space, and this is only available for drivers. So let's just add a driver here, and you'll see down here we have transform space. So what is transform space? So basically transform space is only the actual transformations of these values here. It is going to ignore any parenting, so if our parent moves, it's going to ignore that. If there's any constraints or drivers that change the position or orientation of this child, it's going to ignore that as well. So basically, transform space are these raw input values here. Now, the final thing I want to talk about in this lesson is a local location setting, which is only available for bones. Now, what I'm talking about here is in the bone tab, down here, this local location setting. So with this enabled, its local location has the y-axis pointing off in this direction, because this is the way that I built the armature. And if I grab our y-axis here, it moves relative to its own local y-axis. Now this child bone is parented to this bone called parent, and the y-axis for that one is pointing straight up. So if I disable this one and then grab our y-axis, it's going to use the axis of the parent just for that location. So all the other things remain. So if we rotate on the X, it's going to rotate as expected. It's just going to change the location axes. Now you understand a little bit about space. I hope it no longer frightens you. As I said earlier, all you need to know for now is the local space and world space. And thankfully, those two are pretty easy to understand.